Hello, I'm Emiliano Rios Gavagnin, one of the authors of the work towards an Ontology Engineering Framework for Integrating Visualization, Metamodeling and Reasoning, which is an ongoing and joint work with Germán Braun and Laura Secchi from Universidad Nacional del Comahue and Pablo Filotroni from Universidad Nacional del Sur in Argentina. The aim of this paper is to go towards a framework that enables modeling tools to develop and reason over diagrams represented in different standard languages, such as UML, Entity Relationship, and ORM, and then derive operational ontologies from them. The underlying interoperability is based on a previously developed theoretical metamodel. In this work, we claim that such metamodel is expressive enough to preserve the semantics of the models through different representations, possibly with diverse expressiveness. To begin with, I will introduce you with a motivating example that is a mix between Franconi's and Berardi's phone model. Let us suppose we have this given model and multiple users. As you can see, each user has a different profile, background, and vision of the same domain, therefore they have different preferences towards which modeling language to use. Here is where a unifying metamodel comes up handy. The KF metamodel is a theoretical metamodel that provides interoperability, integration, and conversion of a conceptual data models represented in different languages, such as UML class diagram, entity relationship, and ORM. This metamodel consists of a hierarchy that unifies all main static entities from these three languages and a set of interoperability rules that describes how to transform each language entity into another language. Additionally, these users may find useful to be able to infer on the model or even find inconsistencies. Therefore, working on a model with visual independence is a must for this scenario, as each user can work on the language of his preference and at the same time be able to reason over a collaborative model. Looking at this example, we can highlight three aspects that are our main focus when developing a framework for integrating visualization, metamodeling, and reasoning. First is the visual language independence, allowing any user to work on a model independently of the modeling language. Second is the manipulation of simultaneous languages, and third is the integration of reasoning services. What we propose is a framework called CROWD that has been an ongoing work with the Universidad Nacional del Comahue and the Universidad Nacional del Sur in Argentina. CROWD provides a set of UI interfaces that allows different users to model in UML, Entity Relationship, or ORM. In this work, we implemented the KF API and the KF interface, which provides a subset of interoperability rules of the KF metamodel. These implementations allows the user to model in any of the three languages mentioned previously and transform the model into any other modeling language supported by CROWD. Additionally, CROWD provides interfaces with third-party reasoners, making use of the KF interface in order to reason over a metamodel instance, and not directly on the modeling language bounded model. On the other hand, an old interface is under development in order to use ontology tools like Protoj with the KF metamodel instance. Furthermore, we provide a methodology to exploit CROWD. Making use of the different UI interfaces, the users can create or import models in UML, Entity Relationship, or ORM. Depending on the modeling language, a different set of interoperability rules will be applied in order to instantiate the metamodel. We also give the user the ability to import a metamodel instance previously generated. Using the example shown at the beginning of this presentation, we can see the model represented in UML class diagram, and right below, the same model is shown after being converted into ORM with CROWD interoperability features. In this case, a UML skilled user used CROWD UML UI to create the model. Then, UML to KF rules were applied to the model in order to instantiate the metamodel. Once a metamodel was created, KF to ORM rules were used to generate the ORM model from the metamodel instance. But how is the UML model converted to the ORM model? As I mentioned before, the KF metamodel defines a set of rules that describes how to transform constructors from one language to another. In this work, we implement a subset of these rules in the already mentioned KF API. Let me show you some of the most common rules that apply to almost every basic model. First, it's important to highlight that this set of rules is classified into three categories. One-to-one mappings are rules that convert constructors directly from one language to another. Transformations are rules that require some internal conversion in order to maintain the semantics. And approximations are rules that require some input from the user. In this case, I will show you two one-to-one mapping rules. However, we have also implemented some transformation rules in this work. One of these rules is a mapping of classes. UML classes are mapped to ORM entity types. These two rules describe how a class becomes instantiated in the metamodel, and how it's then converted to an ORM entity type. The conversion is straightforward, but is used in every basic model. These rules will be applied in each UML class of the phone model in order to generate every ORM entity type. Other relevant constructors are relationships. As you may know, relationships in models are essential and exist in almost every model. Relationship rules are more complex, as they involve several constructors like classes, roles, and the relationship itself. Every binary relationship involves two entities and two roles, and it can even involve attributes and constraints, but we will keep it simple in this example. In the phone model, every UML association will be the input of the R1 rule. One important aspect of these rules is that some entities participate in many relationships. Even though the rule definition instantiates the entities for each relationship, CRUD reuses entities previously instantiated in order to make the instantiation process more efficient. Once the relationship is created in the metamodel, the 2R rule is applied in order to generate the ORM fact type. In case you are interested in how this transformation works, you can find more examples in our paper. To sum up, we have presented a unified model in order to get visual independence by leveraging the theoretical KF metamodel. The framework presented integrates visual editing over entity relationship, UML, and ORM conceptual modeling languages along with the methodology to exploit it. Finally, we presented CRUD as a first prototype of a tool supporting this framework and methodology. Future works involves implementing more interoperability rules to cover more modeling languages constructors and extending the compatibility of OWL and the KF for dealing with arbitrary OWL2 ontologies. Thank you very much and feel free to contact us in case you have any doubts or if you wish to know more about our work.